Thank you, Suzanne, and welcome everybody. Good to be here at this great meeting that we've had the last couple of days. So, if you look at the original agenda, you'll see that this was the title of the talk. It's been changed slightly, like Suzanne introduced. I'm going to focus things a little bit. So, Prinos is a site in the Mediterranean, so that's the link. But I'll also be describing a project, a EU-funded project that's just starting right now. We had our kickoff in the beginning of January, called COREu, and it's using Prinos as its main, but not only, study site. So just to give you some background on the project is 4 years, as just like I said, started in January, go up to the end of 2027. We've got a total budget of about almost 36 million, of which the EU is giving us 29 of that. It's a very large consortium. It's 40 partners, and we've got a real wide range of different backgrounds, right? We've not only got a lot of research institutes and universities, etc. We've got a lot of industry, but industry from different aspects, right? So we've got not only the emitters, but pipeline companies that are involved, technology providers, etc. So I went through the proposal trying to come up with a real nice, succinct description of the project, and actually I had a little bit of trouble with that just because the topics that are being covered are very wide ranging. So I just took these points out, talking about how we're going to be trying to demonstrate some key technologies. We're going to be trying to look at the entire value chain, CCS value chain. And very important, we're going to be looking at an area that hasn't been as well developed as, say, the North Sea, Central and Southern Europe. But not only in terms of the storage, but looking also at the routes, right? So how we've talked a lot in the last couple of days about how do you get it there? What happens when you cross borders? How do you transfer responsibility? How do you keep track of volumes? These sorts of things we'll be looking at. So the second point, talking about transnational networks, etc. And that we're hoping that this work will eventually help in kind of laying the groundwork for increasing demand and also the investment rationale to try and reduce risk, not in terms of safety risk, but also in terms of economic risk. So we've got four main areas. The first three, we'll be looking at mainly the route. We'll be looking at various aspects I've written there in the bottom left, trying to understand cross-border access, the infrastructure that you need for transporting. These sites, various work will be done looking at trying to assess storage capacity in different areas, looking at doing some environmental monitoring and the risks. In addition to these three sites, our fourth site will be Prinos. I've already mentioned that. Prinos is where we'll be doing a full chain demonstration, small scale. It's kind of a proof of concept at this stage. Um, like I said, I had some trouble kind of doing a summary at the beginning, so I thought I'd very quickly go through the work packages and just try and pick out some keywords to kind of show what the various partners will be looking at items, right? CO2 composition, how is that going to affect integrity of the pipeline? How is that going to affect reactions in the reservoir? Again, the transport networks, how can you design them so that they're efficient, cost effective, etc. Metering. It's not something that's been mentioned, but implicitly it's been talked about, right? Because if you transfer from one transport mechanism to another, you have to keep track of volumes. If you transfer across national boundaries, you have to transfer responsibilities. You have to keep track very carefully of the amount that you're transferring. And that leads into the next point, the concept of multimodal transport, right? And we'll be looking at truck transport, ship transport, pipelines, etc. And then, like I said before, looking at de-risking. The work package 3 is our demonstration work package. divided in two. So the main work will be at Prinos. So I've just listed obviously capture, transport, and storage. I'll give more details on that later in the talk. And then also some technology demonstration that will be done for showing some new techniques, some new industry developed um, systems for transferring CO2 and injecting it. The fourth one, like the title of the project, which I don't think I actually mentioned what COREu stands for, but it's CO2 routes across Europe. And so this one will be looking at, we've got quite a few tasks in here, but looking at scenarios. Okay, what are the geological scenarios in these routes, in these areas for storage? The infrastructure, techno-economic, cost benefit analysis, governance. Governance is an important thing because there's been the mention about, oh, are we having the possibility of transferring from like Austria to Hungary? Well, different laws maybe were developed based on the EU directive. Um, how can these networks be developed in an optimal manner? And again, can we look at risk? And then finally, work package 5, policy framework. Again, looking at, there'll be one partner, I think it's Bologna, that will be mainly looking at kind of at the European level. And then individual partners kind of in the site, where the sites are, will be looking at national regulation and how things can be harmonized. Social acceptance has been mentioned many times in the last days. We'll obviously be looking at that specifically in the areas of the four sites. Environmental assessment, that's where La Sapienza is doing most of its work, um, involved in monitoring of the Prinos site. Obviously, there'll be monitoring done at the other three sites as well. And then risk studies. And then the last point here is looking at life cycle analysis of various aspects. So if I can just give you a little bit of background about Prinos itself, our main site that we'll be studying. So Energian, the oil and gas company, is the operator and has 100% working interest in the license of Prinos. Prinos is located in the northeast of Greece towards Turkey. So they've moved fairly quickly. So in June 2021, I think the first talk on yesterday was talking about how some countries have incorporated CCS into the recovery and resilience plan, and Greece was one of them. So Prinos was accepted to for application for that. The following year, Energean was able to get an almost 2-year license to explore the site, specifically for CCS, for CO2 storage. The company had subcontracted to Halliburton to do an estimate of capacity, and they came up with two numbers. The first was the larger of the two, 2.5 to 3 megatons per year. There's a smaller one I didn't list, was about zero point 0.5. It's a smaller reservoir in the same general complex. In the start of last year, the EU-funded Hercules project got started, and Prinos is involved in Hercules. And then just this January, like I said, COREu just got started, and Prinos is a fundamental aspect of this project. A couple other points that can be raised for this site is that Prinos has been accepted and put on the list, a European list of so-called projects of common interest. So that gives it high visibility and high importance. And then Energean has also been quite active in looking for companies that will provide the CO2 once they get up and running, right? And they're quite important because there's no point in this huge investment if you don't have the CO2 to inject. So they've already signed a total of 8 memorandums of understanding with emitters for a total of almost 5 megatons per year, which is actually more than is estimated that they can inject at. So that's a good sign. They know that they'll have CO2 to put in. So that's kind of the point up to now, with, time-wise, what's happened. The future, what the plan is of Energean, they've divided it into two phases, which is kind of similar to what Mary was saying for Rivanina. That the first stage is going to be first quarter of 2026, and they're aiming for an injection rate of about 1 megaton per year, and that will be CO2 in compressed form. And then during the second phase, they're hoping to ramp up to 3 megatons per year, um, and be able to receive liquid CO2, and that's aiming for the first quarter of 2029. This is the reservoir complex at Prinos. It's a low relief faulted anticline. You can see that we have two main fields, the Prinos, which is a major producer, and then the Epsilon field off to the left there. We're looking at Miocene turbidites and clastic sandstones. And the idea for CCS is to actually inject below the reservoir, so into permeable sandstones below the oil reservoir. And so we have to highlight the fact that this is not EOR. Right. So that's the reservoir. The cap rock is quite interesting. So we've got 800-meter thick sequence, and not only do we have, okay, sorry, so that's the interval of the reservoir beneath. And what we've got is not only thick sequences of claystone, which are obviously relatively impermeable, but what's quite interesting about this site is we have thick sequences of evaporite deposits, to the point where a total of about 7, I think, sequences, where the bottom two are actually about 50 meters thick each. And the advantage of evaporites is that they have the potential of self-sealing. So even if you have motion along a structure, you can have dissolution, then reprecipitation, and self-sealing of structures along it. And obviously evaporite um, just by itself has extremely low permeability. The work that we're planning on doing within COREu at Prinos. So like I said before, we're trying to look at the full um, value chain, small scale. I really want to emphasize that. The CO2 that we'll be getting is actually by collaborating with another EU-funded project, High Record, which will be building and installing a pilot CO2 plant, an innovative technology, not your standard amine extraction. They will provide it, and COREu will design, install, and operate a conditioning and compressing station so that it can be transported on site. In terms of transport, the first stage will be using actually trucks and large volume cylinders that can withstand high pressures. And so this kind of leads in well with other discussions that we've had so far, talking about small emitters, and if they're not linked with the network of pipelines, what other options do we have? And so our partner, industry partner, is going to be, they've already developed high pressure canisters that can be fit on trucks or trains. And they, I think, are trying to increase the pressure threshold that they can carry, so which obviously mean more mass that each one can be carried. That will be transferred to the city of Kavala, which is on shore in front of where the storage is, and then that gas will be transferred. There's still discussions on how that will be done. I'm guessing it will be done by ship and then injected on site. The injection depth, like I said, is going to be below the reservoir at about 2.7 to 3 kilometers depth, and the total pressure will be at about 110 bar. In addition to this, we're going to be doing various monitoring. Again, we've talked a lot about microseismicity, and that will be addressed in COREu as well. both using the existing monitoring system that exists in Greece, but also installing sea bottom geophones. In addition to that, they will be mounting PCO2 and P sensors on autonomous underwater vehicles that will be looking at trying to glide along the pipelines and monitor for any leakage along that. In addition, we'll put PCO2 sensors on the sea floor in the area of the injection well and potentially also high risk areas in terms of the geology. And we will also conduct seasonal baseline monitoring via ship for sampling of basic chemical and biological parameters. So as I mentioned, this project has only just begun, so obviously I can't present you any of our results, but I hope in the not too distant future that I will be able to show the great progress that we've made. Thank you very much.